Good afternoon. Today we will be continuing with our topic of software engineering, in which we were in the last lecture we were talking about the very important and probably the first phase which begins when any software project is to be developed, and this phase, as we all know, is the requirement analysis and specifications phase. So we have talked about software engineering as a domain and what are the important phases, what are the important steps which are required in the process of making software, in the process of creating new software. So in out of these phases, now we will be going on step by step, and we will be looking at in-depth way at the different phases individually. So now we are going to start with the first phase, that is requirement analysis. Besides this, in this lecture we will also be talking about the different modeling techniques which are required when software are created. So we wanted to know that how the software which is not yet made, how do the software designing team, or how does the engineers, the software engineers who are going to build this software, how are they going to communicate with the client side? For client side means the people for whom the software, the company or the organization for whom the software is going to be developed. So we were talking about that there are some techniques which are commonly used for this kind of communication between the engineers and the clients, and the vice versa. So for this there are different models which are used. So basically, what is a model? A model is basically a reduced representation, which is actually a simplified abstraction of a system. So basically this model is nothing but it is, it's a simple model, it's a simple representation, maybe which is smaller in size, which is simpler in functionality, and this is used to basically help understand how the system is going to work or how the system is going to look afterwards. Then it is also an important tool to communicate between the different stakeholders or who are going to use the final product. So it is a communication tool between the designers team themselves, and also between the designers and the client side party. So basically it's a very important tool for communication, and besides this it also helps in controlling and guiding the process of implementation. So how the implementation is going to take place, what are the steps which are going to be followed, so it acts, this model will help in determining that. So basically it is you can say another term which is used very commonly for models is prototyping. So prototype is nothing but it's a functional model, so which helps you, which makes you understand how it is going to see. So you can, the common analogy would be that if you want to build a house and you go to an architect, so initially the architect is going to show you a model of the house, or how the sample looks like, and with that you understand, it gives you a better understanding of how the final house is going to be. Then looking at that you can communicate and you can pinpoint exactly what are the changes you want or what are the specifications you want, and then you can also control and help in producing the real output or the real product. So basically a good model should possess some very important qualities. So first quality that a good model should be, that it should be an abstract model, that is it should be more logical model than more physical model, and it should be mainly drawn for creating an understanding. So it should be easily understandable. If the model itself is very complicated and it takes time to understand the model, then the whole purpose of the exercise is defeated. So it should be abstract, then it should be easily understandable. Another very important attribute of a good model would be that it should be accurate. That is, it should show the working, it should have the functional and structural requirements of the final product. Then it should be predictive model. So looking at the model you can predict that how the final outcome of how the final product is going to be, and then it should be inexpensive. One cannot spend more money on simply modeling technique and creating the model. So it should be inexpensive, so not a very considerable amount of funds and time, inexpensive in terms of money, inexpensive in terms of time and effort. So it should be easily creatable, easily understandable, but yet it should be accurate and it should be more or less similar to what the final outcome is going to be. So there are different models which are commonly used in the field of software engineering, and these models are used to convey a lot of things. So there are different modeling notations which are used. So the first is the natural language. So natural language, which can be English. So this is natural language, but the problem with natural language is that there is it can lead to a lot of ambiguity, and it is verbose, it is more or less, it is vague, and no automation cannot be performed using this technique. But the advantage is that since natural language is easy to follow, so anybody and everybody can understand English. There is no requirement of any kind of specific training to be given. Then the next kind of model which is used is an ad hoc model, ad hoc notation or ad hoc model, which basically means which have bubbles and arrows. So it is also again simple, there is no particular syntax required, no special training is required. But again this is not clear and this is ambiguous, and there is no automation which can be performed on it. Then the next type of model which is used is the semi-formal notation or the semi-formal model, which uses the unified modeling language or similar kind of thing. So this is basically, this has some syntax which is well defined, like you have well defined graphics, you have well defined symbols, the partial common understanding, so it is reasonably easy to learn because the symbols and all, they are more intuitive to use. So partial animation is automation is possible with the use of this semi-formal kind of structure, but it can also lead to some kind of ambiguity because it can be interpreted in several ways. So in the last modeling notation which is done is the formal modeling notation, where we use specific techniques for modeling the system. So the syntax and the semantics are very clearly defined in this case, and also they can be easily automated. But again the disadvantage is that since it is a very formal notation of defining the model or defining the structure, so therefore it may be difficult for any and everybody to understand. So one has to have a technical know-how of the language and the technique which is used for modeling. Therefore the formal modeling notation is more difficult to understand, but it is more precise, it is more accurate, and there is very less scope for any kind of ambiguity to creep inside the model. So basically modeling notations, we generally prefer that informal language is always better because it is easily understood by all stakeholders when we are talking about software. It is good for understanding the user's requirements, contract. But there are some problems, as we've already discussed, that it lacks precision, then there are possibility of ambiguities, and there is lack of tool support for natural languages like English, etc. So you do not have specific tools, and when you are writing in natural language, so the terms may be used which may be vague, sometimes when they may not be precise, and they may be subjective use of words. So this can lead to some kind of difficulties. Also because the domain knowledge of the stakeholders differs, so therefore this modeling notation, even though it is preferred, it may lead to some kind of problems if there is not a robust channel of communication between all stakeholders in the process. So formal languages, they are more precise, but there are fewer possibilities of ambiguity. These offer support, like there is automated verification and transformation is possible, but they are more intended for developers, they are more intended for technical people, and they are less aimed for the client side or for the naive users or for the people who have less technical knowledge. So basically modeling notations have to be chosen according to who has greater say or who is going to use the model for more greater proportion of time in the software project. So if it is a more client side oriented, cliently heavy oriented project, then we would go for an informal. But if it is for more in-house communication between the developers, then we can always think of going for a formal language modeling notation. So when we talk about modeling structures, there are different modeling structures which are used. So we've already seen in databases we use the concept of entities and their relationships. So we've already talked about the ER model or the ER diagram, where we have entities where all the objects in the real world, they are treated as entity. They have special graphical symbols to show the entities and also to show the relationship between these entities. So basically these are entity relationship diagrams which can be made, and there is always this is one of the older ways of doing it. Then of course we have unified modeling language class diagram. So again, this is a standard language for creating modeling diagrams. So this is again a graphical tool, but which is more standardized in its approach, and it's an easy tool for showing the structure or for showing the representations and the relationships among the different entities in the system using a graphical way. So this is more easy and intuitive and even better easily understood and implemented than the ER diagram. Of course, then we also have the relational tables, which also are important modeling structures which are used in heavy database intensive projects and all. So basically modeling structures, when we talk about models, so we have different types of models. So first very important type of model is the domain model. So domain model is the model of the problem domain basically. So here we talk about two models or two versions of the domain model. Domain basically means the area where the system is going to work on. What is the area in which the system is going to work on, for which the system is being developed. So one model will be the existing model, what is the system now, and then the other model will be what is the system going to be. So there is an existing model and there is a to be model. So system is to be built. What system is to be built is the to be model. So basically it models all input and output data structures, what are the different dependencies and how the system has to work. So and data existing model will represent the present state of the system. So one can easily compare between these two models and see what is the difference in the process and the procedures going to be once the new model or the new system is in place. Then the next type of models which are more commonly used for domain data or for databases, that is known as the database model. So in database model, it is the model of the stored data, not necessarily an image of the domain data. So additional data is introduced later on, for example users preferences, etc. So basically this is a model which models the database or how the data is going to be stored. So it is basically not exactly what all domain data is, but it is simply an introduction and further data can be added to it. Then besides this, there is also the architectural design model of what the system is going to be, how the system is going to behave. So architectural design model is also prepared for seeing the final layout or for seeing the final design output of the system. So when we do a model analysis, so there are different ways in analyzing the model. So they basically you can analyze the model by construction, that is we learn by questioning and describing the system, what the model is going to be. Okay, then we have inspection, that is execute and analyze the model in our minds, whether it is reliable or not. We ask several questions, how the model is going to work, we inspect it, we find out what are the flaws in the model, and then we get to know how the final system is going to behave. Then by formal analysis of the model, so we require more mathematical tools and semantics and syntactical knowledge is required for this. And basically what we are trying to see is that this approach is more reliable in theory, this formal analysis of the model, but it becomes very expensive when we are talking about in practical implementation. Then also by testing the models, we can test the robustness of the system, how the system is going to perform. We can execute the process in the model and we can see how it is going to perform. So it's possible to interact directly with the model, that is it's a working prototype of the model, or you can see, you can give the input and you can provide the output, and then you can see how well the system is performing. So there are different analysis of the model which are done, so that when the model has been finalized, the final product can actually be coming out of the same model and it is acceptable by the user. So there are different types of modeling approaches which have been used over the years, and they have been growing over the years. They have been changing with the changing software paradigm. So there is the structure approach, structure analysis approach, then there is object oriented analysis approach for the modeling. Then we also see the problem frames are there which are created, then state machine based analysis is there, then conflict analysis. So different types of analysis of the modeling approaches have been done to find out how the different models can be suitable for different situations. So basically it is important to distinguish between the notation, that is the model, and the process. So notation basically means it's used for defining the model, how the model is defined, and process is defined as a sequence of activities leading to a desired model. So what are the activities which were involved while you were developing the model? So analysis can be made on individual requirements, or analysis can be made on specific requirement of the system. So tricks, and it's always better to note the requirements and then to go ahead with the modeling thing. So basically now what we are going to talk about is the requirement specification process and the steps which are required in the requirement. So basically requirement definition is a comprehensive process, and it is the very important, one of the most important and critical processes in the entire software engineering or software development phase, because if this phase goes wrong, that means that your entire system is going to be flawed, because if the system is not understood well, then it means it is not going to be implemented well. So basically in requirement definition we talk about 4 different types of phases or 4 different steps which are required. First is the requirement elicitation, that is you list what are the requirements, then an analysis of the listed requirements is done, then a proper document is prepared which is requirement documentation, which is software requirement specification document, and then you have a review of the requirements where both the teams meet and they review which requirements are genuine, which are required, which are actually which can be avoided, or which can be postponed to the next phase of the development cycle. So basically software requirement specification is the document which will help us in two basic steps. One is the requirement change management and the requirement traceability. So basically what happens is, one of the most problematic area of software requirement is that the requirements keep on changing. So during the process of the software development only, the requirements of the user may change. There are several reasons for this kind of change in the requirements. One is that the user, because the system is non-existent, so the users may not, the clients may not even be aware of what to ask for, because it is a completely new idea for them. So one is that they don't know what is the new requirement. Secondly, they have so much of in-depth domain knowledge that they make certain decisions as intrinsic. So they implicit basically. So they think that this will implicitly be happening. So they fail to understand that there is this domain expertise gap is there, and therefore certain things. Then there are some other requirements which are unknown. So even the people who are using the software at that time, they don't know. So basically it is important that we prepare a document called the software requirement specification document, which will help us in tracing how the requirements have been changed, how the requirements have shifted with time, and also it will understand how this changed requirements have to be managed or how they have been managed. So a proper documentation is necessary condition for this step. So basically requirement definition, when we talk about what is requirement definition, so the software must provide a means of representing and accessing external files created by other tools. So requirement specification should be provided with facilities to define the type of external files. So basically we are talking about a specific kind of system where what are the requirements from the system, what are required. So according to the IEEE, the software requirement is defined as a condition. Requirements basically is a condition of capability needed by a user to solve a problem or achieve an objective. Another definition says that a condition or capability that must be met by the system to satisfy a contract, standard or other formally imposed document. So basically when we say requirement, we mean that the final system that we want should meet or should satisfy these following conditions, and these conditions have been laid in a standard document, in a formal document, and therefore these conditions will be binding on both parties. So requirements basically means what is the system expected to do, and we will also try to understand that in this requirement phase we only try to figure out, we only try to find an answer to what the system is supposed to do, and we are not going to talk about how it is going to do that. So this is the second phase, that is the implementation phase, which we are not going to talk about. Even in the requirement phase, never the designers or the developers, they talk about how. Even erroneously, if they start talking about those paradigms or those algorithms of how the requirements are to be, they need to be checked. So it is only a phase where the team listens and it tries to gather how the requirements are, what are the requirements, what is the user expecting the system to do, and only trying to document all those requirements with the persons. So basically when we talk about requirements, there are different types of requirements. We can categorize the requirements from a software into different categories. So the first category of requirements are the functional requirements. The next category of requirements is the non-functional requirements. Then we have the performance requirements. Then we have some kind of domain requirements. Now requirements have also further been classified in as other classifications are also given, like for example user requirements and system requirements, or we can have based on the knowledge of the user. So there could be some requirements which are known, some requirement which could be unknown, and some requirements which are absolutely unthought of, that is they are even not, they are called undreamt requirements. So we are going to talk about each of these specific kinds of requirements and what is the implication if either of these requirements is not fulfilled, any of these requirements is not fulfilled in the final system. So basically the first type of requirements are the functional requirements. So these are statements of services, what the system should do. Basically it talks about the input which the system will take and how the system, and what is the output that the system will produce when the input is given. So it also talks about how the system will react to particular types of inputs, or it will react in particular situations is important. Like for example, if an invalid input is given, or there is an error in computation, or there is an invalid output which is being given. So how the system is going to behave when these kind of situations are met. So basically functional requirements, they talk about input and the output. What is the input which is given to the user, and when that specific input is given, what will be the output that the system will generate. So functional requirements basically deal with the functional aspect of the system, that is the working of the system. Basically it is required, it is relevant to the working of the system. Then we have the non-functional requirements. So non-functional requirements are basically, they are more important, they are more difficult to be met, and these are more critical for the success or failure of the system. So these are like something like the constraints on the service, or the functions offered by the system such as timing constraints or constraints in the development process or any kind of standards. So these are non-functional requirements. We will study a large number of different categories of non-functional requirements. Then we have some performance requirements, that is how the system is going to perform. So there could be static requirements and there can be dynamic requirements. So static requirements which are relevant to the performance of the system could be like the hardware which is available, the number of computers which are available, or what is the capacity of the system, or there could be how many users can log into the system at one time, or what is the maximum number of files which can be opened at any given time, or what is the maximum size. So basically they will define, these are also known as capacity requirements. And the other requirements which are relevant to performance requirements are the dynamic requirements, or which basically are more related to the dynamic aspects of the software, like for example the response time. Response time is how much time the system is going to take to respond back with a query or with the result of the query. Throughput is how much time is the how many instructions the system is going to execute in the given specific time. So there can be different types of performance requirements which can be stated, and these should be stated in very clear, unambiguous terms. If we say that the system should have a good response time, so this is not the correct way of putting it, because it has to be very objectively put. So and similarly the system can allow large number of users to log into it. No, this is not the right way. You must specify the system can in normal situations allow 100 users to log into it. The throughput of the system will be so many lines of code in 1 minute. So these have to be very categorically and very specifically be stated, because if these are not stated that way, later on the difficulty will be in assessing whether those requirements have been met or they have not been met. Then another type of requirements are the domain requirements, that is which come from the application domain of the system. So they reflect basically the characteristics of that domain. So every domain is different. For example, a software which is created for a hospital may have absolutely different requirements from what a software for a library is required. So basically they come from the application area where the system is going to use, and therefore each domain may have its own specific requirements. For example, a software which is being developed for military operation has to be very, very secure. So their security is the critical domain, whereas a software which is being developed for users or for simply students, maybe elementary students, or so for them the ease of use will be an important criteria or an important requirement which the software will have to fulfill. So therefore domain specific requirements are also there, which need to reflect and which need to be fulfilled, because these are important traits of the domain for which the software is going to be developed. Then talking about non-functional requirements, so these define properties and constraints. For example, reliability, response time, storage requirements. Constraints are input-output device capability, system representations, etc. So these may be more critical than functional requirements, because if these are not met, then the system becomes almost useless. So more than the functional requirements, it is the non-functional requirements which make the system a success or a failure. So these requirements these are basically not directly related to input output, but they talk about the other yardsticks or the other metrics based on which the performance of the system has to be evaluated, based on which the performance of the system is actually met. So if we talk about non-functional requirements, we can see here they can be categorized into multiple heads. So the first is the product requirement. So what are the requirements, non-functional requirements which are expected from a product? So basically it is efficiency, that the product should do what it is destined to do, reliability, that is it should be fault tolerant, it should not have failures, then it should be portability, that is this product should be interoperable on different platforms, hardware as well as software, Then usability, it should be easily usable, there should be ease of use, the people who are using it should not find it too cumbersome, it should be simple enough. Then performance of the system, how what is the time required for the system to respond, what is the throughput, what is the response time, etc., and how much space is it going to take. Then there can be various organizational requirements like delivery, implementation and standards. Then for example, there could be other, like for example, external interface requirements are also there, which mean there are some legislative issues or some standard safety issues are there. There are some privacy issues which are specific to a domain, which could be specific to an organization. When we are talking about the interface, so the interface between the software and the user, the interface between this software and other softwares in the system which are already working. So all these interfaces have to be designed carefully. Nowadays it is very important to have a good robust user interface being given to the user, because it is tough fight and the users are more prone to having a good graphical and visual experience of the software. So unless the software provides a good experience, a good user interface, a rich interface to its users, then it may not be able to make its place. So therefore external interfaces, be it through laws, be it through the statutory bodies, be it to other software, be it to the people who are working. So all these interfaces are also very important. If the system fails on any of these non-functional requirements, then no matter how good the system has scored on the functional and other requirements, it may be difficult to make its place in the work culture or in the workspace of the organization. So basically there are different non-functional requirements which are known. Then other types of requirements could be, the other way in which requirements can be classified is known requirements, like something a stakeholder believes to be implemented, which he knows it is going to be implemented. There can be unknown requirements which are forgotten by the stakeholder because they are not needed at that time, or they are not needed only by another stakeholder. So another department or another person in the company the kind of requirement has this kind of requirement, so this is sort of missed out. And then there could be some unthought of or undreamt requirements which the user is not able to think at that moment because of limited domain knowledge, or there is lack of foresight, or even if the laws change, for example. So then the requirements of the user will change accordingly. So the user's requirements could be known, unknown or unthought of. And when we are talking about these, so these requirements could be either functional or non-functional requirements. Any kind of requirements could come into known, unknown and undreamt of requirements. Then another set of requirements is what are the user's requirements and what are the system's requirements. So users, basically there are different categories of people who are going to use the software. So they'll have their own, each set of user will have its own set of expectations, its own set of requirements from the system, and the system itself will also have some kind of the procedure or the functions which are in place will also have their own specific kind of requirement. So basically users requirement should be they should be desirable, functional or non-functional requirements, as they are understandable by the system users who don't have detailed technical knowledge. So these should be basically very easily put and easy to understand and easy to convey to the user. So these are basically defined using natural language, tables and diagrams. So easily the user can put in and the user can understand that his requirements have been understood by the software development team. So again, we've talked about what will be the problems when we are doing this. There will be a problem of predictability, there will be a problem of functional, non-functional confusions will be there, and there will be a blending of requirements, what we call as requirement amalgamation. So when users who are non-technical users of the system, their requirements have to be understood, it is very important that we use a form based approach. So basically a form is a structured way in which users requirements can be gathered by the team and in a more structured, in a more formal way, and it can be documented and well understood. And then in the next phase, when there is a review of the requirements which is going to be done, then again the users can come back to it, or the team can come back to the users. So therefore natural language becomes a little problematic when user requirements are to be stated. Then there are some system requirements which are more detailed specification of users requirements. So they serve as a basis for designing the system. They may be used as part of the system contract. So these are more formal requirements, and these are the requirements which will form the basis according to which the system is going to be developed. So they are very detailed in nature, they are very specific in nature, and they are absolutely statutory and binding requirements on both the parties, that is the developer team as well as the client side team. So now what we have discussed so far is that we have understood that a user can have varied kinds of requirements, and these requirements have to be understood by the software developer team. Now the software developing team who is already understood this requirement, they use several tools and they use several kind of exercises to gather these requirements, whether functional, non-functional, like we have discussed just now. They could use simple tools like English language, they can use tools like verbal communication, formal, informal communication with the stakeholders, they can use some kind of forms, they can use interview, structured, unstructured, closed-ended questions, open-ended questions. So they will try as much as possible to collect all the requirements, and then they will try to formulate a document, and this is a very critical document in the entire process of software development. This is known as the software requirement specification document, or the SRS document. So basically this document, it specifies the external system behavior, how the system is going to behave with the outside world, and this document should be something which is easy to change, because as we've already discussed that the requirements may go on changing endlessly sometimes. So till the time the requirement documentation is not frozen, requirements are not frozen, there could be possibility that this requirement document is changed. So basically it will also serve as a reference tool for maintenance in the future, maintenance of the system. Whenever new requirements will come up, the people will refer to this and they will say that this is how the requirements have changed over time. Then record for this is also a record for thought about the life cycle of the system. That is, it can predict the changes, what changes are going to happen, and then it also characterizes responses to unexpected events. So how the system will react, how the system is going to respond if any kind of unexpected events take place. So unexpected event could be a functional change, or it could be a non-functional requirement change. So basically this is a very important document which will help in many other ways. So now we'll do an in-depth understanding of what a software requirement specification document is. So basically it is useful in various contexts. Firstly, it is a statement, in the most simplest words, it is a statement of users' needs. What are users' requirements? Then it also serves as a contract document. So it is a legal document which is a contract, which is a binding document. Whatever is stated in the requirement specification document is a part of a legal contract, and the software developing team has to provide whatever has been signed as the SRS. Then it also becomes a reference document in the future when they have to look back and they have to study, the team or the clients, they have to study that if there is any problem in the software, then they can always go back and study that whether it was a part of the requirements or not. And when implementation is going to take place, this is going to be a vital tool, because based on this requirement specification only, the design as well as implementation of the software will take place. So at the time of implementation also, Even after that, for maintenance purposes also, this document is going to be a highly critical document. So basically it is a reference document. So it is a contract between the development team and the customer. So once the SRS document is approved by the customer, any subsequent controversies or they are settled by referring to the SRS document. So this is what I said, that SRS document will be used at any future time, at any point in time ahead, whenever they will have a conflict, whenever they will have a disagreement, then the teams, both the customer as well as the development team, will go back to the SRS document and refer to it. So the point is that because of this, the SRS document will become a very important and crucial document for the software requirement as well as the customer team. So once the customer has agreed, then the development of the product will start according to what has been specified in the SRS document. So the final product will be acceptable to the customer as long as it satisfies all the requirements which are recorded in the SRS document. So once it is approved, only then the design and implementation of the system will begin. Whatever has been recorded as requirements in the SRS document have to be provided by the development team, and it has to be acceptable to the customer, because they have also signed that document which states that how the system is going to behave, what are the things the system is going to do, and what are the different aspects of non-functional requirements which the system is going to cover, what will be the standards, the metrics that the system, the minimum metrics which the system will meet as far as the performance of the system is concerned. So basically a software requirement document is a black box, because it only specifies the external boundaries or the external behavior of the system, and it does not talk about the internal details. As I already said, that it is only going to talk about what is the input data and what is the output data. It does not discuss the algorithms, how the input is going to be converted into the output. So it is very visible, okay, and the behavior is documented. What the system is going to do will be categorically clearly documented in the SRS system, in the SRS document. So therefore it is sometimes also called as the black box, because it is a completely abstraction. It only talks about what is the system going to do and not how the system is going to do what it is going to do. So therefore implementations are completely hidden at the time of the SRS document. It does not even talk about the structure of the various system it is going to be. It only talks about the basic requirements which the system is expected to fulfill. So it actually concentrates on what needs to be done and not on how. So it should be very carefully written, because later on it will serve as a legal contract between the two parties. So there should be no ambiguity, there should be no contradictions, there should be no kind of vague use of words, and there should be very, very specific terms which are used. For example, we use standard terms that the system shall do this. So shall will be used to show mandatory, and the system should do this means optional. So wherever the word shall comes, so it is understood by both parties that this is a mandatory function which the system must do, whereas wherever the word should is coming, it means that this is an optional feature, and if it is provided, it will be an extra advantage for the system, but it may not be provided. At the same time, it may not be provided. So therefore standard terms have to be used in this kind of a scenario. So the requirements should be used using end user terminology. So later on they can be formulated, they can be used, they can for development team they can be formalized, they can use any other tool or any other language, but at the time of writing the document, at the time of preparing the document, it should be written using a language which the customer understands, because it is very important that both the customer and the development team, they agree on it. So it should be it should be used using natural language or any other language which both users can understand easily. So basically, if we talk about requirement specification document, so you can understand that it has 3 layers. Firstly, it is the data model, then it has a functional model, and then it has the behavioral model. So it will only talk about the specific system requirement specification, will talk about all the 3 models, but it will not talk about how these 3 are interlinked to each other, how they are going to work on each other. So it is going to identify what are the entities in the system, what are the various data objects for which data needs to be stored in the system. Then it will also talk about what are the different functional entities in the system, what are the different processes which the system undertakes, how input is converted into output. But if, for example, it says that the input X is converted into the output Y, so it will only talk about this conversion, but it will not give you the formula which is going to be used. The formula will come at the time of design and implementation. And then it also talks about the behavioral model. Behavioral model basically is the non-functional model of the system, where the system its interaction with the outside world are more concerned. So the software requirement specification, since we are saying that it is a very important and a very critical document, so it should have certain attributes, certain important qualities should be there, and each of these qualities should be, these are desirable qualities of any SRS document, because these document should meet with these standard qualities. They should have these, they should possess these attributes in order to be considered as a good requirement specification document. So the first is that it should be correct. That is, it should be a correct requirement document. It should note down, or the points which are written in it, they should be very clearly and very correctly, accurately mentioned. Because if the true requirements are not listed in it, the time specifications are not, then it is wrong. So if the requirement specification, if the understanding of the requirements is not correct, then all the other things will not fall into place. Then it should be precise. That is, eventually it has to run into an executable code. It has to become a computer program. It is to develop into a logic. So the use of fuzzy words and the use of abstract verbose language should not be acceptable. It should be very precise and very objective language which should be mentioned in this document. Otherwise, later on there can be a lot of conflict, and which can be difficult to resolve because of the use of this kind of informal language. So this is very important. The rules should be clearly defined. Unambiguity is another very important attribute, because generally this is required, this is written in English language. For the user's sake, it is natural language, so it is used in English language. Now each requirement should be interpreted only in a single word, in a single meaning. There can be multiple understandings of each word, but which should not be allowed here. So only a single one line understanding, one line interpretation should be allowed. Then it should be a complete document. There should be nothing which should be left for future or which can be added later. It should be to the at that point in time it should be complete, which includes all aspects of the system, including the behavioral aspects, which involves different models which can be used, the data objects, the data models, and the functional models. So it should cover all the 3 dimensions of that particular model. Then it should be verifiable. That is, the software which is built with using the SRS should be verifiable. That is, the software and the SRS, they should be similar. They should talk in the same language. That is, they should fall exactly same to each other. So there should be no difference between the requirement specification document and what was put in as in the program or in the final implemented software. Then it should be consistent. That is, conflicting terms should not be used within the domain or within the context of the document itself. Sometimes we see that the terms which are used, they are not same, or they can have differing meanings. So this should not be allowed. Then it should be understandable, that is, questions are formal specification, these should be informal specifications are also understandable. So they can be easily understood and they can be easily interpreted by the customer, so that they know that whatever has been put in the requirement specification is exactly what they want out of the final system. Then it should of course be modifiable. The requirement document should be flexible enough, because it should be easily modified when specifying, designing, coding and implementation. There are sometimes situations that there are some requirements which may be accepted at the time of coding, but later on it is found that they are not practical, they are not viable, they are not feasible. So in those conditions, this requirement documentation should be modifiable. Then it should be traceable, that is, all the origin of the software components comes from the software requirement specification document. So the origin of each object in the system should be traceable to some requirement in the document. You should be able to relate that the component X of the system is a result because the user had some requirement R from the system. And last but not the least, that it should be design independent. So it should be platform independent. Whatever platform, as we've already said, that it is a black box. So it can be used, it can be designed using any platform, implemented using any programming language, it can be for any hardware architecture. So it should not, the requirement specification should be indifferent from all these details which are going to follow later on at a later stage. So basically a good requirement specification document should follow all these aspects of all these traits which we have discussed. So I think that will be all for today, and we will be continuing with the requirement specification in the following lecture. Till then, thank you.